So we're now going to be looking at how we can estimate things like 3.5 squared without the use of a calculator. Or when we're going to go on to it, we're going to look at things like 2.9 cubed or 1.9 to the power of 4. How can we estimate these? So the first thing you might think is, well, 3.5 squared, it's got to be somewhere between 3 squared and 4 squared, right? So 3 squared is 9, 4 squared is 16. So 3.5 squared's got to be somewhere between those two. Now you might think, well, maybe it's perfectly halfway between 9 and 16. So to work that out, you can add 9 and 16 together and divide by 2. That gives you 25 over 2, which is 12.5. So this essentially finds the mean of those two values and gives you the midpoint. So is 3.5 squared exactly 12.5? Well, the answer to that is no, it's not. 3.5 squared is not equal to 12.5, although it is close. Now, what we can do is we can think, well, okay, well, can we come up with a method that will be able to estimate these values? And one way of doing that might be to think, well, okay, so what if I looked at the difference between 16 and 9? Okay, so I look at that gap. 16 take away 9 is, of course, 7. Now, I've got 10 bits here, haven't I? Okay, so going up from 3 to 3.1 to 3.2 to 3.3, and so on up to 4, I've got 10 pieces. So what if I thought about, if I've got a 7 gap, then I do 7 divided by 10, and that's 0.7. So I could go up in 0.7s. So starting with 9, I could go, well, 9.7, then 10.4, then 11.1, 11.8, 12.5, 13.2, 13.9, 14.6, 15.3, and then I'm up to 16. So 3.5 squared is about 12.5, 3.4 squared is about 11.8. Well, let's see how far we are off using that method. And this seems like a perfectly good method. So I'm going to work out what each of those are using my calculator, just so I can do it quickly. Okay, and now I'll work out the difference between our estimates and the actual values. Okay, so a couple of things to note then. Our estimates are always slightly above the actual values. Okay, so our estimates are always overestimates here. That's the first thing to note. The second thing to note is that when we're in the middle, so 3.4 squared to 3.6 squared, these are the ones that are the most out. Okay, so the ones that are in the middle, that's where we are the most out, but at the tail ends, we're pretty close. Okay, so taking this forward, we're going to see similar results for cubing and then to the power 4, but even more pronounced. And these gaps, these differences, become larger the larger the value that we are squaring as well, or cubing. So if I looked at 8 squared up to 9 squared, these differences would be larger. So as we go through estimating, we'll use this method, this kind of interpolation method, in order to help us estimate. But don't worry if we are a couple of integers out, okay? A couple of whole numbers out. So if I estimate it to be 12, but it's actually closer to 13, that's still fine, okay? Because remember, it is only an estimate. But we'll see if we could take these ideas on board as we go into our examples.